Hi, everyone. Welcome to this video. We're going to be talking about how to find the sum of the exterior angles using the algebraic process. Okay, so we're going to use algebra to figure this one out. Now, we're going to soon switch over to Agile Mind and be able to follow along with what they're doing, but I wanted to see if we can set it up ourselves first. So the first thing we need to figure out is, okay, using what we've already discovered about exterior angles, right? We've seen some other ways to imagine it. We've scaled or dilated the polygon in order to see that, well, when you shrink it down enough, it looks like you're just cutting slices out of a pie or wedges, right? We've also seen it as, maybe you've seen it, thinking about, okay, well, if I'm going around a polygon, right, and ending up back where I started, because all polygons are closed, you need to go all the way back where you started, that's 360 degrees, right? So we got two visual ways, two real world ways to see why it has to add up to be 360. But what about, algebraically, the abstract reasons, because if it equals 360, there must be some formula that tells us that. Well, we also know about interior and exterior angles, remember. We know how to find the sum of the interior angles, and I think we can use that to find the sum of the exterior angles by connecting them somehow. So the first thing we want to use to connect it is that the measurement of an interior angle, right, plus the measurement of an exterior angle, remember, that equals, what was it again? 180, right? They're supplementary angles. Anytime I have a shape like this exterior angle and this interior angle add up to be 180, right? This is a connection for one of the angles, but what about for all of the angles, right? If I was to do this for every single one of my exterior angles, like so, what's that going to look like? Well, for all of them, it looks pretty similar, right? Just making all these, see, it does it for each of them. So I need to do this 180, how many times for a triangle? How many times for a square, right? How many times for a hexagon? Well, if you look at it, it looks like the number of times we're doing this calculation of adding them up to equal 180 is the number of vertices we have to look at, right? So I could do this n times for each of them. So the sum of my interior angles, right, plus the sum of my exterior angles, that's going to equal 180 degrees times n, right? And now let's switch to the Agile Mind so we can follow along with them, okay? Because I think it'll be a little easier if we do that. Looking at Agile Mind, you're going to see it's exactly where they're starting off, right? We know that individually, each of those vertices is 180, so that putting them together and adding them all up to find the sum of both the interior and exterior angles is going to be 180 times n, right? Now, how can we keep moving forward? Because we don't want to have sum of interior and sum of exterior. We want to solve for just the sum of the exterior. So is there a way that we can replace the sum of the interior angles with something else, something that is in terms of n, right? Because if it's in terms of n, I'm able to solve it. So consider that for a second. Let me pause the video and come back if you think about what formulas we have that tell us the sum of the interior angles in terms of n. Okay, so hopefully you've considered that, right? You've thought about it for a second. You paused the video and tried it out yourself, maybe. What you'll see here is that the sum of the interior angles, we have a formula that tells us that in terms of n, right? That formula was that we know a triangle is 180, a square is 360, a pentagon is 540, or in other words, it's 180 for every side beyond the second, because you can't have a polygon with two sides, right? So every side beyond the second, or n minus 2, right? This is the sum of the interior angles for any polygon with n vertices, n sides, right? We still got our sum of exterior angles. I'm going to call this SOE because I don't want you to write that out every single time. And now we have 180n, right? Or maybe I will even just call SOE. We'll use a variable for that, so E, okay? So let's solve for that. How am I going to do that? I need to start by simplifying some stuff, right, to get things easier to move around. So to simplify here, 180 times n minus 2, I'm going to distribute. Right? I'm going to distribute this, if you remember that from maybe middle school or algebra class. So 180 times n is 180n, right? 180 times 2 is 360, but it's subtracting that, right? So it's minus 360 plus e equals 180n. Now what you'll see is we have 180n on both sides of the equation. So if I subtract 180n from here, I also subtract it from here, subtraction property of equality, right? And I end up with e minus 360, just rearranging a little bit, equals 0, right? Well, if e minus 360 equals 0, that means by using the addition property of equality, we know that e is equal to 360. Or in other words, the sum of our exterior angles is equal to 360 degrees. And if you follow along with Agile Mind, that is exactly what they're going to do. It's exactly what they do. So the first thing they're going to do is replace the sum of the interior angles with the formula that we used, slightly different order, right? The next thing they're going to do is distribute, distributive property. Just like we did, right? Then we're going to take away whatever we had, right, to leave us with just the sum of the exterior angles. That is 0 on that side. And over here, it's going to be a little more complicated of a simplification. But you can see the 180n minus the 180n. And then minus minus gives us a plus 360, right? We are left with the sum of our exterior angles equals 360 degrees. Now, what's great about this is algebraically, this must be true, right? Using things we already knew to be true, we have proven this. But we also just saw reasons why it makes sense for this to be true in the real world, right? Geometrically, by seeing it as turning around a polygon, right? Or as wedges of pies made by the polygon slices, right? It works out to make sense that it's 360. So when your algebra equation tells you something equals 360 degrees, consider why it might equal 360 degrees, right? Think about why it might equal a circle, or why it might be the same thing as going all the way around, okay? I hope that explanation makes sense, and I hope you have a great day. Thank you.